Hello students, in today's session of CBSE paper 2025 paper discussion, class 12 subject physics, topics ray optics and optical instruments and wave optics will be discussed in detail with additional information. In earlier session, we have gone through very basics on ray optics and optical instruments, very basics on wave optics, and also PYQs of from CBSE Board. Quick revision 1, 2, 3, 4, 5, 6, 7, 8. Topic is mentioned, date of release is also mentioned here. Right? So you can go through on YouTube channel SethiSwiftLearn. As the session is going to be very important, it is requested go through the session completely. इसी के साथ साथ मैं रिक्वेस्ट करूंगा, अगर अभी तक आपने YouTube चैनल SethiSwiftLearn सब्सक्राइब नहीं किया, please subscribe it and share with the colleagues and friends. Now let's start with the question and concept. Question is, a tube is filled with a transparent liquid to a height of 30 centimeters. The apparent depth of the coin lying at the bottom of the tube is found to be 16 centimeters. The speed of light in liquid will be, concept applicable in solution. What is Snell's law? Snell's law is 1 mu 2 equal to mu 2 over mu 1 equal to V1 over V2, V equal to F lambda, F remains same, lambda 1 over lambda 2, lambda over lambda 2. The meaning of this is refractive index of medium 2 with respect to medium 1. Also, in this case, it is applicable real depth upon apparent depth. Real depth upon apparent depth. So this comes out to be 30 upon 16, 30 upon 16, and V1 over V2. Velocity of light in air divided by velocity of light in medium. We have to find V air over V medium, that is 3 into 10 to the power 8 divided by V medium equal to 13 upon 60. Right? On simplification, this comes out to be 10, 1.6. V medium comes out to 1.6 into 10 to the power 8 meter per second. This is the answer. Let's check the answer. Correct answer is A. Right? Next question. In a double slit experiment, 6 dark fringes observed at a certain point of screen. 6 dark fringes. A transparent sheet of thickness T and refractive index N is now introduced in the path of one of the two interfering waves to increase phase by 2 pi n minus 1 T lambda. The pattern shifted to the earth's right fringe is observed at the same point. Find the relation of thickness T in terms of n and lambda. 6 dark fringe means 2n minus 1 lambda by 2. That is 2 into 6 minus 1 lambda by 2. That is 11 lambda by 2. Now, phase introduced additionally in one of the paths, that is 2 pi n minus 1 into T by lambda. You know the relation between time period, phase and wavelength. Then corresponding to this path difference will be, new path difference will be introduced, n minus 1 into t. Now, effect is at the same point, eighth bright fringe, that is 8 into lambda. Now, make the equation, that is 2n minus 1 lambda by 2 plus n minus 1 t equal to n lambda. Here n equal to 8 lambda. Here n equal to 6 bright fringe, dark fringe. So this comes out to be 11 lambda by 2 plus n minus 1 into t equal to 8 lambda. 8 lambda. Then simplify n minus 1 t equal to 8 lambda minus 11 lambda by 2. 5 lambda by 2. 5 lambda by 2. So t comes out to be 5 lambda upon 2 n minus 1. This is the relation between all these three. Means initially 6 bright fringe. Introduce a transparent slab of thickness. Phase difference introduced. Reducing this into path difference. This is equivalent to path difference. That at the same position we obtain the 8th bright fringe. So this distance plus this distance equal to distance. Simplify t in terms of n and lambda. Right? Next question. Question is, two concave lenses A and B, each of focal length 8 cm, are arranged coaxially 16 cm apart. इन दोनों के बीच की डिस्टेंस 16 सेंटीमीटर गिवन है. An object P is placed. This is the object at a distance 4 cm from A. This is 4 cm. This is 4 cm from A. Find the position and nature of the final image form. You know, lens formula is one over V minus 1 over U equal to 1 by R. First of all, concept applicability, we will consider find the position of image from this, that will behave as an object for this. Again apply the lens formula, again calculate it, that will be the final position of image. Right? For A, V equal to VA, U equal to minus 4 centimeter, F equal to minus 8 centimeter. For using the sign convention, right? 1 over VA minus 1 upon minus 4 equal to 1 upon 8 with negative sign. Now 1 over VA equal to 1 minus 1 by 8 plus minus 1 by 4, 8 minus 1 minus 2 minus 3 by 8. Means VA comes out to be minus 8 by 3. Means for lens A, position of image is at a distance of 8 by 3 centimeter to the left of A. Left of A. Now this will behave like an image for lens B. Now position of object for this will be UB. Position of object for B will be, that is 16 plus this will come out to be 8 by 3. 16 plus 8 by 3 48 plus 8 by 3, 56 by 3 centimeter, right? Again using the mirror formula, again using lens formula. So 1 over V minus 1 over U equal to 1 by F. Now we have to find final position of VV minus U minus 1 by 56 by 3, तो 3 ऊपर कर दिया, ठीक है, equal to minus 1 by 8. 1 over VB equal to minus 1 by 8 plus minus 3 by 56. On simplification, 56 minus 7 minus 3 minus 10 by 56, 1 over VB. VB comes out to be minus 5.6 centimeter. That is final position of image of object placed at point P is 5.6 centimeter to the left of lens B. Lens B. That is the answer. Right? Next question. Question is, when a parallel beam of light enters water surface obliquely at some angle, what is the effect on the width of the beam? Concept applicable in solution. This is a parallel beam. Now, this after refraction bent towards the normal, this after refraction bent towards the normal, right? Means, now, this is the original width of parallel beam in the air, and d dash is width of beam in water, right? This angle of incidence, this angle of wavefront. Now, in this triangle, N1, P, and 2, cos I will be equal to cos I. This is 90 degrees, this is the hypotenuse, this is the base upon d upon x, and cos R in triangle N1 and 2, Q N1 and 2 in triangle. Cos R will be equal to d dash upon x. Cos R, this is R, this is 90 degree, base upon hypotenuse, right? So cos I upon cos R equal to d upon d dash. Now, as ray of beam is entering from denser medium to rare medium to denser medium, therefore this ray will bend towards normal. Therefore, angle I is greater than R. Then cos I will be less than cos R, because as the angle increases, sin increases, and cos decreases. Cos I less than, so cos I upon cos R is less than 1. So this d dash, d upon d dash is less than 1. D is greater than d dash. Means width increases. Right? Now question. Question is, with the help of ray diagram, show that a straw appears bent when it is partially dipped in water and explain it. Second part is, explain the transmission of optical signal through an optical fiber diagram. Concept applicable and solution. This is the straw. This is the observer. Now this is a simple going. When the ray of light after refraction from water surface enter to the observer eye, it bent towards away from the ground. When it is traced back, it means that the pen appears to bend. Appears to bend when these rays are extended back to meet at this point. Right? This is the image formation and explanation. And second is optical fiber. How the light ray follows TIR. Its signal is transmitted through total internal reflection between core cladding and this one. Right? Next question.
Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE Board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very helpful and useful, which you can review on YouTube channel SethiSwiftLearn. In addition to this, I would like to say that these papers, complete video of sessions are available on SethiSwiftLearn YouTube channel, which you can review on SethiSwiftLearn. In addition to this, further, these papers, detailed solution with additional information available on website SethiSwiftLearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल SethiSwiftLearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question.
A thin pencil of length f by 4 is placed coinciding with the principal axis of a mirror of focal length f. Image of the pencil is real and enlarged. Just touches the pencil. Calculate the magnification produced by the mirror. According to question, as image is real and enlarged, and mirror is concave in nature. Mirror is concave in nature. And you know, magnification is given by V upon U to I upon O. Size of image over size of object. That is the magnification. Concept will be here to use this formula, right? And using this one. Now formula is U will be in this case, this is a pencil. Object. And this is the image of pencil. This is our mirror. This is concave mirror. C is optical center. And their distance C is always 2f from the floor. This is 2f. Now find the position of, so this will be position of V. So U will be equal to minus 2f minus f by 4. On simplification, this comes out to be 7f by 4. That is V. And V will be equal to 2f plus x. 2f plus x with negative sign. Both are the same side. According to sign convention, we have to put the negative sign. And magnification is given by minus V upon U इक्वल टू आई अपॉन ओ। आई दे रखा हमें, आई इज एक्स एंड यू इज O is f by 4, right? This comes out to be minus v upon u. Minus minus is not cancelled, so फिर again minus. This comes out to be 2f plus x upon 7f by 4 equal to I upon o, x upon f by 4. On simplification, we get x equal to x comes out to be minus f by 3. If we simplify it, we get x equal to. Then magnification will be equal to I upon O, that is x upon f by 4. X is minus f by 3 upon f by 4. On simplification, this comes out to be minus 4 by 3. Magnification is minus 4 by 3. Answer. Right. Next question. Question is, a ray of light is incident on a refracting face AB of prism ABC at an angle of 45 degree. The ray emerges from face AC and the angle of deviation is 15 degree. The angle of prism is 30 degree. Show that the emergence ray is normal to the face AC from which it emerges out. Find the refracted axial material of the prism. There are two parts to be found out. One, we have to prove that emergent ray is normal to the face AC, and second, refracted axial material of the lens. Now, according to question, this is the face AB, this is the face AB. Given हमें angle of prism, that is A. A is given to you 45 degree. ABC angle of prism is 30 degree. Angle of prism is 30 degree. And angle of deviation is delta, is 15 degree. Angle of incidence is 45 degree. This is angle of incidence 45 degree. This is 30 degree. This is 15 degree. We have to prove that E equal to 0. E equal to 0. We know the relation A plus delta equal to I plus E. I plus E. I is 45 degree plus E equal to A 30 degree plus 15 degree. Therefore, E comes out to be 0 degree. 0 degree means emergent rays is normal to face AC like this, right? In that case, R2 will be equal to 0. To find mu, you know, according to Snell's law, sin I upon sin R1. Sin I is 45 degree upon sin R1. Sin R1 comes out to be, as we know, R1 plus R2 equal to a R1 plus 0 equal to 30 degree. R1 comes out to be 30 degree. So sin 30 degree. On simplification, 1 by root 2 upon 1 by 2, that is root 2. Mu comes out to be root 2, or you can say 1.414. Refracted index of the material of the prism. This is the basic diagram. This is the incident ray, then refraction, then again this is incident on this and this. If E is 0, then R2 will also be 0. These are the relations in this case applicable. Now, next question. Question is, light consisting of two wavelengths, 600 nanometer and 480 nanometer, used to obtain interface fringes in a double slit experiment. The screen is placed 1 meter away from the slits, which are 1 meter, 1.00 nanometer apart. You have to calculate the distance of the third bright fringe on the screen from the central maximum wavelength. So xn equal to n t lambda over d. The distance of nth bright fringe from central maximum. In this case, given n3, d is given to you. The screen is 1 meter apart. T is 1. This model distance between the slits is 1 nanometer, and lambda is for 600 nanometer. Therefore, x3 will be equal to 3 into 1 into 600 divided by the 1. Nanometer is 1. So answer comes out to 1800 meters, that is 1.8 into 10 to the power 3 meters. This is the answer of part A. Now part 2. Part 2 में करना है हमने. Find the least distance from the central maxima where the bright fringes due to both the wavelengths coincide. Let n of shorter wavelength length bright fringe coincides with n minus 1 of longer wavelength bright fringe. Therefore, n into lambda longer, n into lambda shorter equal to n minus 1 into lambda shorter. So that comes out to be n into 480 equal to n minus 1 into 600. On simplification, n upon n minus 1 comes out to be 6 upon 480, that is 5 by 4. So 4n equal to 5n minus 5. So n comes out to be 5. Means fifth bright fringe of wavelength 480 nanometer will coincide with fourth bright fringe of lambda equal to 600 nanometer, and this distance would be x5 over लेंगे 5 into 480 d lambda upon d1 upon 1. That comes out to be 2.4 into 10 over 3 meter. Whether you find the distance from this or from उसमें लिखेंगे 4 into 4 into 2.4. That is the answer. Right? Next question. Question is, draw the variation intensity of the angular diffraction in a single diffraction pattern. Write the expression value of angle corresponding to zero intensity locations. Second part is what will diffraction light wave differ from diffraction of sound waves? Concept applicable in solution. This is the variation of intensity with angle theta. Intensity goes on decreasing, where and relation between that d sin theta equal to plus minus n lambda or e sin theta plus minus n lambda, where d or e is distance between the d e or d distance between the slits. Distance between the slits. In this way, it will goes on decreasing. Second part is in what way diffraction light will differ from the diffraction of sound waves. In case sound waves, it is easier to observe diffraction because the wavelength sound is comparable to the size of the obstacle observed in daily life. This is the basic difference, right? Now, I would like to request, if you are new to my YouTube channel, SethiSwiftLearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.